Good morning, ladies and gentlemen, and welcome to the JEC World live demonstration area. We are back even bigger and better this year. This is the place to be at the JEC World to discover all of the groundbreaking technology and creative innovation which is shaping the future of composite manufacturing. My name is Joanna Morion, and I am delighted to be your host of this dynamic and interactive demonstration area. We wish to extend our sincere gratitude to our fantastic sponsors, Thermwood and Aerovac Composites One, as well as our valued partners, Roctool, Magnum Venus Products, and Virtech. Thanks to their ongoing support and collaboration, we are able to bring you front row seats to witness all of the latest technology which is at the forefront of composite manufacturing. And now, ladies and gentlemen, without further ado, let's get into our first demonstration this morning with Roctool. We are delighted to welcome back Roctool to the stage once again. Roctool is a specialist of rapid heat and cool technology for plastic injection and composite molding. Their patented processes are currently in production in many sectors such as defense, aerospace, automobile, all the way to sports and leisure. This morning's demonstration is going to showcase the Roctool Fusion, or RT, Roctool Thermal Fusion, or RTF, which is a manufacturing solution that fuses multiple composites directly into the mold to create a fully consolidated structure. Please give a very warm welcome to Matthew Boulanger, the CEO of Roctool, and Edouard Philippe, who is the Composite Business Development Manager. Gentlemen, the stage is yours.
Thank you, Joanna.
Hi, Joanna. Thank you.
Good morning, everybody. Thank you for spending some time with us. We'll try to make it entertaining. Can you hear me okay? All right, great. So Edouard is here, Hugo is at the press machine. So a few words about Roctool before we start this demonstration. We are a heat and cool provider. We've been in the industry for more than 20 years, and we provide heating and cooling systems that we apply to thermoset applications, thermoplastic applications, and more. It's funny because the last few days we've been talking about some of the JEC we've been doing throughout the years, and we always try to push processing limits, you know. We always challenge ourselves to come and do demonstrations. We could decide to stay and just have a couple posters and show a couple parts, but no. We decided to make it the difficult way. So we bring our machines, we bring our system, we bring our tooling, because this way you can actually see what we do and what we can offer. And I think demonstration is the most important thing you can do as a company to show to your customers. One thing I can tell you about the company, we provide engineering services. So based on the part that you want to make, either it's a thermoset or a thermoplastic part, we look at what our heating and cooling solutions can do to speed up the cycle time, to simplify the process. I'd like to highlight this one. And number 3, potentially to make a better part. That could be surface quality, that can be yield, that can be some of the surface defects that could be a problem. So when we talk about surface and when we talk about process simplification, this year we decided to come with our heat platen. So we have a press machine with a heat platen, our induction system. Edouard will give you all kind of details. But what's interesting this year is we're going to gather multiple steps of molding in one. So we're going to use one cycle to do multiple steps of manufacturing to make a 3D structural part, which typically you do in secondary process. Here we're going to do all in one. And for that, this year we're making a paddle racket structure in carbon fiber and polycarbonate. So a few words about the demonstration.
Yeah, thank you, Matt, for this answer.
We should start.
Yeah. Before just to start, just summarize about the equipment. So we are the press and our ridge platen, and we show you the manufacturing of the racket paddle frame. So we start to close the press. Before that, of course, we are lay up a thermoplastic composite preform with a silicon blader. And we can start now the live demonstration. The total cycle is around 12 minutes. Integration with heating, holding time, and cooling. So we have time also to present you the equipment in link with this demonstration.
Yep. So what are we showing this year? We're showing a material that is not consolidated. So we're taking a pre-preg, but in thermoplastic, we're going to say organosheets or many different ways of describing it. But it's unconsolidated. And we place it in the tool. We have a silicon bladder because it's a hollow part. So we need also the internal pressure. And what we're going to do with the heat platen, we're going to go to 260 Celsius, 260 Celsius. We're going to hold to get the full consolidation. But before, remember, we talked about having multiple steps. So what are those steps? Number one, I do my consolidation as I mold my part. So I don't need to buy a fully consolidated sheet where some of the value is already going because it's fully consolidated. I can use a material that is pre-impregnated but not consolidated. As I mold, I do my consolidation. Number three, if I have multiple parts that already are consolidated or metallic inserts, brackets, some of the fixtures, I can place it in my tool, and as I do my consolidation, as I do my forming, I can also weld multiple components in one, which typically would be reserved in a secondary operation and so on. And finally, I could have another piece that maybe was molded before in a section of the part that also would be bonded and welded because it's the same matrix. So in one shot, in these 12 minutes, because we're using a heat platen and an aluminum insert, we make a structural component in a one shot.
But you can see, so we start the heating with our induction generators. I will describe the power and the range of our equipment in the next slide. But we are able to reach, in this case, for this live demonstration, 100 degrees per minute. So in less than 3 minutes, we'll be able to target the temperature transformation to 60.
Yeah. And we know that this cycle time, this is because we're at the show and we're using the heat platen. Let's say you have a high volume production. You could switch to have a tool that has a dedicated induction network and not use the heat platen, and then the cycle time would be 5 minutes total. So it would be even faster. And that is also a way to avoid preheating of the material, transferring, automation. We use directly from a cold mold, place in the tool, full cycle, and demold.
One important know of Roctool is also to be able to make advanced engineering study to define the performance of the solution. So in this information that we share with you, we are able to define the temperature behaviors of the process during the heating, the holding, and the cooling with thermal simulation. So as you see on the slide, we can define by advance the heating ramp. And as you see, we can also control a different temperature and different heating performance between our heat and cool platen and on the insert mold. That's the two different curves that you have in black and in gray. And you can see that we can have a gap between the reeds, which is our heat and cool platen, and the insert mold to be able to optimize the heating ramp. So that's the view of what you have in front of you.
Yeah. The thing is, when you know you have induction heat capabilities, and with our engineering, we can decide what is the best tactical heating that we can look based on a form factor. Because some of the parts, they don't need to be heated everywhere. It could be a local heating because you want to accomplish something specific, or it can be a full heating because you want to consolidate a part. Obviously, you need homogeneous. That's why we have thermocouples that gives direct information. We have a interface, a specific interface where we can pre-program cycles, and then every cycle will be exactly the same.
So the advantage will be able to heat, for example, the reeds platen at 20, 30 degrees higher than what we want for the insert mold. and to limit the overshoot with the setup of the program that we have on our interface.
Could we take a look at the equipment?
Yeah, sure. So for this live demonstration, we have several equipment that I show you with the camera. Come with me. So we have our bestseller equipment, which is our induction generators here. It's a Roctool DC 50 kilowatt. So it means that we have 2 times 50 kilowatt to be able to manage separately the top and the bottom side of each platen. This is our conventional equipment based on this configuration. We have also the capability to deliver Roctool 100 kilowatt and Roctool 150 kilowatt, depending the temperature range and the size of the application. With this equipment, we have our mold cooling unit. This is our C6 cooling unit with a performance to deliver 100 liters per minute. So this equipment is connected to a chiller to be able to deliver water flow at 20 degrees during the cooling phase. And with this equipment, we also are able to purge the platen or the mold, depending the configuration, to be able to, when we want to reheat, to do not have energy limitation with water inside the system. And close to the C6, we have our W18. That's the system to cool down some component that we are in our generators, or also in the configuration of our reeds platen. So that's the full package that we are able to deliver. And as explained by Matt also, we are a specific interface that can be connected to the press. It's our RT31. It's a new interface with a movable HM that you can have here. So we can manage, as you see on the screen, the 2 sides of the platen. So we see here in live that we are again in holding time. So we just spend a little power energy to stabilize the temperature at 260 with only 7 kilowatt per side. So we push power to stabilize the temperature, and we manage all the cycle on this interface.
So based on the thickness of the material, the temperature level, the shape, cycle time, has many different factors. That what we know is that today we're making parts that can be very tiny on multi-cavity tools for consumer electronics, for instance, all the way to aerospace parts that are very large and that can be more than 3 meters. So it's all about finding the right configuration for your application. And with this induction heat, you have the flexibility. Also a very important point, when you look at oil heating or electrical cartridge, it takes quite some time to get a mold or a press machine in temperature. Even when you're not molding, there's an anticipation where maybe half a day of getting ready, preheating the press or preheating the mold. With induction, you don't need to. As you can see, we just started the demo and we're at 270 C. Then we're going to stop and everything will be off, no energy consumed, and then we'll be ready for this afternoon's demonstration. So that's also interesting about what we call the non-manufacturing time, and there's no energy spent when you're not using the process.
One important thing also is that we manage the system with thermocouple. So we have several thermocouple for each side of the platen or inside the tool. And with this thermocouple, we are able to manage heating and holding and cooling time during the cycle. You can see also that we can have a very good tolerance in terms of temperature. In this demonstration, you can reach plus or minus 2 degrees during the heating and holding. That is very important for different materials from thermoset and thermoplastic, and have a very good control for homogeneity.
We have 3 range of temperatures. In general, we have range for thermoset and low heat thermoplastic. So we call it all the way to 200 C. We have second range all the way to 300C for more advanced polymers. And then we have ultra polymers like PEEK, PEC, and others where we go beyond 400C. And that's also the advantage of the induction is once you're set up with the induction, if in the future you have other materials coming in for a project, you're not limited. It means that you can easily switch to a much higher heat material.
Also, the package of the equipment that you see here can be used for different configuration for the heat and cool platen, but if you change, as I already said, with a 3 high-tech mold, you can stay with the same equipment and use it for this kind of application.
Exactly.
And so it's very flexible.
Exactly, because this part here is made with an aluminum insert, because the heat platen is doing all the work. But if we wanted to do high volume, and we wanted to have a much reduced cycle time, doing the same exact part, we would have a steel tool with the induction in it. But for the show, we picked this configuration. We feel that the heat platen is very versatile for many applications, so longer cycle time, but easy to swap inserts. Maybe next year we'll do the other one. So we're cooling now?
Yeah, we start the cooling. So also the cooling is very quickly, very rapid. So we cool down at the demolding temperature around 95 degrees, 100 degrees. So in less than 2 or 3 minutes. So it's as we make a crash cooling. So we push a flow of water inside the reed platen. But in this configuration, we have also water cooling circuit inside the insert mold to optimize against the cycle and to be more performant in terms of cycle.
So just a quick question before we open from the attendants here, how many are only using thermoset materials? Okay, how about thermoplastic? So there are some that are not using either thermoset or thermoplastic? Okay, so thermoplastic is growing. Like yesterday, we did the quiz and many people raised their hands. I think that we can see there's a trend ongoing and more thermoplastic solutions are being used, which is great. But thermoset is still strong.
So now we have quite finished the cycle. So again, few seconds before the demolding temperature. So as you see, in less than 12 minutes, maybe, we are able to manufacture this example of racket paddle frame. And in a few seconds, we can open the press and demold the part and restart a new cycle easily.
Exactly. So typically on this component, with the silicon bladder, we can have the inner structure, and it gives you also up to 15 bars of internal pressure, which is required for a good consolidation. What's interesting is we get also a resin-rich surface. We can see the polycarbonate that is driving well on UD, which then allows the manufacturer to do decoration step and be able to decorate the piece.
We can also add that in this configuration and demonstration, we use carbon, but all the system can be used with a large different material, from glass fibers, carbon fibers, of course, as we say, and all natural fibers. So you can adjust as you want, depending the processing, the material in link with your application. So it's easily, you keep the same equipment, and you have just to manage different temperature in link with your material.
Yeah, in this configuration, we have a silicon bladder, but we have parts where we don't need silicon bladder. If it's a 2D shape, we would just have a standard tool and do a normal demolding. They wouldn't need a... So this one is a little bit more tricky because it's a loop of silicone going through the whole structure. And plus the resin that gets on the surface, when we demold, we need Hugo's talent to do that.
So we open the press, and in a couple of minutes we demold, and we can show you the final parts already manufactured.
Exactly. The last few years we did demonstration with a non-woven material. We did UD this year. We do woven material. We also do combination of the two. There's some sandwich structures where we can mix and match materials based on the application. So that's also interesting with the induction because you can have different steps of temperatures. If you have complex layers of materials with multiple materials and you need to reach different steps, you can pre-program your cycle to reach separate steps. So that's also interesting in some of the thermoset applications that require to reach different steps. And that's something we've been doing, again, for 20 years with this technology that we keep improving. Perfect.
So let's see the part
Nice.
consolidate, as you see. So we have a little flash of resin that show that we have a good reach the good temperature
We love flash.
and
Means,
the good melt. So we have just a little trimming
Exactly.
to have a final
So
part.
if you want to come see the part, we have trimmed a couple from yesterday so that you don't cut yourself, but you're free to come and check the final result. And this is it for the demonstration. We're ready for questions. Easy ones, please.
Ladies and question for the gentleman over on with the blue shirt. Somebody's going to give you a microphone. There you are.
Hello, thank you very much for the demonstration. Can you show us the
let's
individual
let it.
components that you're going to load into the mold?
Sorry?
Can you actually show us the individual preforms and components
Oh, yeah,
that you're
sure.
loading inside?
On a une préforme? We can show you. Yes. That's easy. If there's a difficult one, it's for Edouard. Yeah, yeah. At the time we pulled preform, any other ones about the process or anything? The gentleman?
Thank you very much for the demonstration. I would like to ask about your thermal management. How is the thermal management strategy you have? Because for large parts, you need to have the same temperature overall to make sure that the
Correct.
characteristics
Even for
are
small
same.
parts.
Even for small parts, yes. So,
Yeah.
that's
So
the question.
we-
I hope that's not difficult.
So we use two things. First, we have a 2D, 3D software, and before making the mold, we locate the inductors. You know, we have inductors, channels, inside the heat platen or the mold, and we decide where we position them in the tool. Okay? So that's one. And then, when we manufacture the tool or the heat platen, we have thermocouples that are in different sections of the tool that give us the feedback on the interface to make sure that we reach the temperature that we need to reach. So this way, we have live temperature control of the mold surface. Not temperature at the machine. We don't care about this. We want the temperature in the tool. Thank you.
We can add also that
yeah, so-
depending the size, but if
So we have our
uh,
silicon bladder, and we have laid up pre-consolidated, pre-preg material, and then we mount it in the tool, and so on. So here, obviously, it's I don't want the carbon on me, but obviously here it's 3D, but we also do 2D. We wouldn't require the silicone and so on. Here, well done, Hugo.
Yeah.
Any other questions?
All right, well, thank you very much. You have a question?
Yes, I have a question for you. Could you just remind us of the different sectors where the RTF technology is relevant, please?
That's easy as well, thank you. So we're in aerospace, defense now as well, consumer electronics, sports and leisure is growing. We're in the automotive. We also do injection molding. Our technology is growing in the world of injection molding to quickly heat the mold right before injection and then fast cooling. And that's a way to get rid of weld lines, sink marks, improve surface quality. We work in the automotive for interior trim, exterior trim, lighting components, polycarbonate, PMMA, and so on. So it's a heating technology. So we're in blow molding. We do blow molding now in the beauty products, packaging. So think about any tools that require fast heat versus old systems from years ago, like oil or hot water, that we completely outperform because of the speed, and it's dry, it's safe. If you have a leak, you just replace your inductor and you put a new one. So it's user-friendly.
What more could you want?
We like what we do.
That's great. Ladies and gentlemen, we would like to thank Roctool for their
Thank you.
fantastic demonstration.